Okey, wireless transmission media yang seterusnya adalah communication satellite ataupun satelit komunikasi lah, di mana ianya berpusat di stesen angkasa di luar bumi ni lah, di luar bumi, dipancarkan di luar bumi. Stesen angkasa yang menerima isyarat gelombang mikro dari bumi berasaskan stesen, di mana ianya akan menguatkan dan dia akan menyiarkan isyarat dengan secara meluas. World wide lah, maksudnya dia worldwide lah. Dan kawasan yang di cover ni adalah keseluruhan bumi, dan stesen satelit komunikasi ni biasanya diletakkan kira-kira 22,300 batu di atas khatulistiwa bumi tinggi dan ianya digunakan dalam navigasi udara, siaran televisyen dan radio, persidangan video, sistem global positioning system GPS lah, yang kita nak tahu arah ataupun tempat
is a communications satellite. Let's go to Asia Satellite Telecommunications Company Limited, or AsiaSat for short, and find out more. A communications satellite is a man-made machine put into space by a rocket for communications between different locations on Earth. In general, communications satellites are designed to orbit the Earth in one of the three basic orbits: geostationary orbit, GEO, medium Earth orbit, MEO, and low Earth orbit, LEO. Many communications satellites are of the GEO type. They are positioned over the equator, and they appear to be fixed above one spot on Earth. Among these GEO satellites, AsiaSat's first satellite, AsiaSat-1, was Asia's first commercially owned communications satellite. It was successfully launched into space by the Long March 3 rocket in April 1990 from the Xichang Satellite Launch Center in Sichuan, China. AsiaSat today has a fleet of 6 in-orbit satellites placed at 4 different orbital locations, all of them providing services over the Asian landmass. A new satellite is being manufactured to further expand the satellite fleet. Together, these 6 satellites carry over 700 TV and radio channels. They have footprints over 80 countries and regions, reaching up to 2/3 of the world's population. AsiaSat has procured its satellites from the United States. The cost of building and launching one of these satellites is estimated at $250 million, and it takes about 3 years to build a new satellite. Let's take a look at how a satellite is launched into space, and the geosynchronous orbit in particular. After manufacturing and testing, the satellite is put into the fairing of the rocket. After launch, it will then use the rocket's propulsion force to enter the elliptic-type Hohmann transfer orbit, which takes about 30 minutes. It will take 5 to 10 days to perform a transfer to reach a circular geostationary orbit. On the geostationary orbit, the satellite will be moving at the speed of 3.075 kilometers per second, which is about 3 times the maximum speed of a rifle bullet. Finally, the communications satellite is located at its final position for operation, about 36,000 kilometers above the equator, almost 1/10 the distance between the Earth and the Moon. After 1 month of in-orbit testing, the satellite is ready to go into service. A geostationary satellite only appears to be stationary to us on the surface of the Earth, but is in fact in constant motion because of the gravitational forces in space. Therefore, AsiaSat's satellite control staff need to issue commands from time to time to steer the satellite back to its relative position towards the Earth. They also need to adjust the orientation of the satellite using the attitude control thrusters aboard. Generally, a communications satellite uses either chemical thrusters or ion thrusters for the slight adjustments. The astrological positions in space will also be used for calibrating the satellite's attitude control to make sure it is pointing correctly towards the Earth. Let's take a look at an AsiaSat satellite to get an idea of the satellite structure. The satellite is equipped with 2 solar panel arrays, and each array contains 4 solar panels. They are always facing the sun, converting sunlight into electricity, providing up to 10,000 watts of power for its operation. These are the large parabolic antennas used for communications with the ground control station. They are mainly responsible for receiving and transmitting various communication signals, but they also receive work commands from ground control. The small parabolic antennas and feed horns are responsible for transmitting and receiving information at different frequencies. Other hardware on the satellite includes radiator panels. Their function is to dissipate heat generated by the electronics on board the satellite. Traveling Wave Amplifier Tubes, TWTA. They are used for amplifying the signals for transmission. Spacecraft communications electronics for processing information throughout the satellite. Onboard thrusters for making adjustments of the position of the satellite. And the propulsion tanks. In the next 2 episodes, we will talk about satellite transmission.
Okay, jadi dekat video ni korang dapat tengoklah secara macam mana satelit itu bergerak dan sebagainya.